right, let's warm it up a little bit. Do our one-step equations from back in the day, because today we're doing one-step inequalities. So remember, just keep it balanced. If you do something to one side of the equal sign, you have to do it to the other side. M plus 7, to get m all alone, we have to subtract 7. Do it to the other side as well. 5 minus 7 is negative 2. Here we have to get rid of minus 8. So we will add 8 to both sides. K equals 19. Here you have to get rid of 12. So I know that that says plus right there, but I don't want, that plus kind of goes with the h. And even though you can just reverse the order with the plus, I want you to think of it this way. That's positive 12. So we have to get rid of positive 12, so we're going to subtract 12. Because we're always trying to get to 0. 12 minus 12 is 0. So we just have h equals 9. I have to get rid of minus 23, so we'll add 20. 6 plus 23 is 29. Sweet. So now we're going to bring this in with inequalities. So we have to solve it and graph the solutions. So we're going to have to remember those dot rules and the shading. N plus 8 is greater than or equal to 19. The inverse operation of plus 8 is minus 8. Minus 8 here, minus 8 here. N is greater than or equal to 11. So the only number I need on the number line is the 11. If you want more, great. Greater than or equal to has a solid dot. The letter's first, so let's just follow the arrow. It's pointing to the right, so we'll shade to the right. All the numbers greater than 11 would be to the right of 11. Negative 26 is greater than y plus 14. We get rid of the plus 14 by subtracting 14. They're both negative here, so just add them up and keep it negative. They add up to 40, so we'll have negative 40 is greater than y. It's just greater than, so it has to be an open dot. Now, either rearrange the inequality, or remember, you just follow the arrow if the variable's first, which is not here. So we have to go the opposite way. It's pointing to the right, so we would shade to the left. Or if it helps, rewrite it with the y first. Negative 40 is greater than y would be the same as y is less than negative 40. So if you reverse the order, you reverse the sign. I have 3 examples I'd like you to try. So pause it, try them, and then check your work. Get rid of plus 3 with minus 3. M is greater than 3. Open dot. Shade to the right because the letter's first. Let's see. So here we have to get rid of 8 by subtracting 8. 15 minus 8 is 7. I don't know why I wrote negative 7. Alright, open dot. Shade to the left because it points left, and my variable is first. And over here we'll get rid of plus 7 by subtracting 7. There we go. Negative 3 minus 7 is negative 10. So this is the or equal to, so full dot. The letter is not first, so we're not going to follow the arrow. It points left up here, so we're going to shade to the right. Or rearrange your inequality. However you can remember which way to shade is delightful. Alright, we have a word problem, and then I have a word problem for you to try. Nearly 32 megabytes of memory are available for running your computer. If its basic systems require 12 megabytes, how much memory is available for other programs? So I think at this point in society, 32 megabytes is a pretty small amount. But here's like what's available. let's call it A, plus we have to run 12 megabytes, no matter what. We have 32 altogether. Now, can we go over 32? No. Can we hit exactly 32? Sure. So this would be at most 32, so less than or equal to 32. Now, how do we get rid of plus 12 megabytes? We subtract them. Which leaves us with our availability has to be less than or equal to 20 megabytes. So if we were to graph that, 20, ooh, that would be a closed dot. It's got the or equal to, it's part of the solution, and anything less than this. Now, our inequality graph there indicates that it goes on forever to the left, but realistically, this would have an absolute endpoint at 0, right? There's no such thing as negative data. So a number line doesn't work great for this type of problem. All right, try this one out. An airline lets you check up to 65 pounds of luggage. One suitcase weighs 37 pounds. How much can another suitcase weigh? Here is our first suitcase. We don't know what it weighs. Plus our 37 pounder. It can be up to 65 pounds. So it can be less than or equal to 65 pounds. So we get rid of that 37 by subtracting it. 65 minus 37 would be 28 pounds. So it's the or equal to, less than that. Again, it would have an absolute endpoint at 0, because you can't go less than 0 pounds. All right, and these ones, ooh, now we have to add, okay. All right, careful. So n minus 15 is less than 3. How do we get rid of minus 15? We add 15. 3 plus 15 is 18. So for our graph, we need 18 up there. It's just less than, so it's an open dot, shade to the left. If the letter is first, then follow the arrow. If the letter is second, then don't. And if the letter is third, then I don't know. So I have 3 for you to try. Pause them. Check in when you're done. Here you added 13. Both sides, m is greater than 42. Open dot, shade to the right. Here we have to add 4 to both sides. 7 plus 4 is 11. 4 equal to, solid dot. And it's less than or equal to, so we shade to the left. And here we have to add 5. 11 plus 5 is 16. T is greater than or equal to 16 would be a closed dot. Shade to the right. Fantastic. We did it. We did it.